Hello guys, welcome to That's Logarithmic tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please do press subscribe button and notification bell. Now, so our updates on this YouTube channel. Thank you and God bless you. Amen. Today we'll be considering what 2022 G3 Waec Physics Practical under the branch of what? Electricity. And here is a question before us. I will know that we are going to be doing alternative to practical when it comes to Waec private exam. It's going to be an alternative to practical. So we are not going to practicalize it really. But the information about a practical that has been practicalized is going to be given to you. And then you are going to use that information to answer the questions thereafter. Now here is the questions under the branch of electricity. We are given a circuit diagram. There has ammeter, batteries. We have what? We have the fuse wire box and the lights like that. Now, here a circuit is connected as shown in the diagram above to investigate the dependency of fusing current on the diameter of a fuse wire. The ammeter has a full disc scale deflection of 12, that is 12 milliampere. It's supposed to be 12 milliwatt ampere. Now, a wire known diameter is placed on the fuse box and a key, which is K, is closed. The rheostat is adjusted to increase the current until the wire melts, thereby breaking the circuit. So the IA, which means the wire is read and recorded, and the procedure is repeated to another wire of the same material and diameter, and the physical current IB is measured and recorded. The mean fusing current, look at the word mean, that is the addition, the mean fusing current is determined. The mean fusing current means that A and B is added together and then divided by 2 to obtain a mean current. So to obtain your mean current, IA, that is the current A plus the current B divided by 2 will give you the word, the mean fusing current. Is determined and recorded. The whole experiment is repeated with 4 other wires of same material but different diameter. Figure 3A. Look at this. The figure here, 3A is 3A. Figure 3A, which have I, Roman figure 1, which is Roman figure 1, I, Roman figure 2, I, Roman figure 3, IV, Roman figure 4, V, Roman figure 5, shows the scale. D shows the scale. D diagram of diameter di of the wires used. While the figure 3b and figure 3c shows the 2 sets of ammeter readings, IAI and IBI. So meaning that what? Figure A is telling us about the diameter, and figure 3b is telling us about the first ammeter. The first ammeter for the what? For the IA current, the I subscript A current. While the second ammeter here shows the what? The current of the what? Second wire of the other of the second wire, that is IB. So that is that about, and this figure is telling us about DI, the diameter of the wire. So now we are going to use this 3D diagram to answer the questions that follows. Measure and record the real diameter of the wire using the given what? Scale. We have to measure the what? The diameter of the wires using the what? The scale. Here we are given what? We see it on the what? On the screen. The scale 1 centimeter represents what? 0.25 millimeter. So, and we are going to use this scale to what? To get the real value of the what? Of the diameter of the wire. So the first thing is to get the diameter of the wire, which is D, which is measured in what? The scale said 1 centimeter represents 0.5 millimeter. So meaning that what? For every 1 centimeter that you measure here, it's equivalent to 0.5 millimeter. Please note that for every what? For every centimeter you measure here is equivalent to 0.5 millimeter. So meaning that if I measure what? Let's say, okay, this is my table of value. We have the serial number, the D, which is in millimeter, because we are told that what every 1 centimeter is what 0.5 millimeter. So it means that our diameter is going to be in millimeter. Then what are we asked to measure again before we even start taking our measurement? Read and record the corresponding IA and the corresponding what? IB. So the IA, which is in ampere, and then the IB, which is also in ampere. What else again? Calculate the what? The mean. Calculate the value of I in each case, which is the mean. Don't forget, we are told that the fusing what? The mean fusing current I. So it's going to be what? IA plus IB divided by 2 in each cases. Then what else are we asked to do again? Calculate what? We have to determine the log what? D and the log I. The log D and the log I. Because of the space here, can we just bring it down here? Let me bring it down here because of the space. So we have the serial number. We have the serial number here. The serial number, please follow. We have what? The second column would be what? Would be diameter. Diameter D millimeter. The third one will be what? Ammeter. The I what? The current for the A, which is in what? In ampere. The second current B, which is also in ampere. So we also have what? We also have the mean fusing current, which is I is equal to IA plus IB divided by what? 2. Please note it. Divided by what? 2 is very, very important. We have the log I itself. The log I itself. Then the log D. So that's that about that. Now don't forget we have 1 to 5. So let's quickly do that. 1. That's line 1. Line what? 2. Just trying to manage space. Line what? 3. Then the line what? 4. Then the 5. So 1, 2, 3, 4. Then what? 5. So here, shall we what? Shall we go into the what? To the calculation there after. Now let's go into it fully. Okay, I've cleaned this video so as to have what? More space to work with. Now we have what? We have the first thing here is to measure the what? The D in millimeter. Now we are told that for every 1 centimeter that you measure is equivalent 0.5 millimeters. So don't forget that. So when you see the diagram in your screen, so you can follow what I'm doing here. So if you place your what? Your centimeter ruler on this one now, I measure it, this is about 2.5 centimeter. So the first D1 here is 2.5 centimeter. And if it is 2.5 centimeter, we are told that what? The 1 centimeter of the one for every 1 centimeter. For every 1 centimeter represents what? 0.5 millimeter. So what does 2.5 centimeter represent? So we just say 2.5 multiplied by what? 0.5. 2.5 multiplied by what? 0.5. That's what is going to be equivalent to 1.25 millimeter. 1.25 what? Millimeter. So this is 1.25 millimeter. So you have already put the millimeter on the top, so there is no need for you to repeat it here. So 1 centimeter represents 0.5 millimeter. So what about 2.5 centimeter that you measure? So you cross multiply. 2.5 times 0.5 divided by this 1. So it's because this is 1, that's why I don't divide it by this one. It's because 2.5 times 0.5 divided by 1 will still give you 1.25. So 1.25. So the next one is what? Measure the second one. What is the next second one? What's the length of the second one in centimeter? In centimeter, we have this is 3 centimeter. So 3 centimeter times 0.5, that will be 1.50. So that is 0.5 times 3 that is that times 3.0 give 1.50. So the next one is what? Let's check the next one. The next one is 3.5. 3.5 times 0.5. We have 1.75. So that's that. So the next one is what? Next one is almost like is 4. Almost 4. So this one will be what? 2.0. So the last one here is 4.5. You can see it's increasing by 5. 4.5 times 0.5. 0.5. We have 2.25. So these are the what? Values of what? Of D. Now let's go to what? IA. This is the first ammeter A. When you look at these readings very well, you can see that this is 0, this is 6, this is 12. Now, and how does that mean? What does that mean now? Let's see what each of these lines, small line represent. So, looking at this very well, this is going to be 1, 2, 3, 4, 5, 6. So meaning that this one is 1. This one is 1. This one is 2. This one is what? 3. This one is 4. This one is what? 5. This is the 6 here. 7, 8, 9, 10, then 11. So you have to be very sure of that. You can see that how I label it. So to know this one now, this one is 1, 2. 2 Abi. This is 2. Then what will this one represent? This one will go. These are 5 lines. 1, 2, 3, 4, 5. In between the what? In between the 2 bigger lines, there are 5 smaller lines. Meaning that each line will be 0.2. 1 divided by what? 5 will be 0.2. Because there are 5 lines divided by 1, difference of 1. Because difference between 1 and 2 is difference of 1. So 1 divided by that small lines, that is 0.2. So meaning that what? For every line that you move is 0.2. So this one is so already what? This one is 2 already. So 2.4. The first here is 2.4 ampere. Okay, now going to the second one now, which is the second arrow that we see here. Second arrow here, very close to 4, but not 4. So this is 3, this is close to 4, it's touching the line before 4. So this is 3.80. Next line is what? 5.0 exactly. 5.00. So please note that this is 5.00. Now the next one is on this, which is after what? 7. So this is 7.20. 7.20. And the last one here is very further. So this is 1, 2. Then we can see that this is what? On 3. So on 3, that is what? That is 11.6. 11.60. So that's that about that. So let's go to IB. When you look at IB, same process. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. This is 6, this is 7, this is 8, this is 9, 10, then 11. Now with that so we can now say, okay, what is the first one here? The first one here is this 2 Abi. This is 2.4. So this one is 2.4 as well. The I1 here is 2.4 as well. 2.40. The next one is 3 point what? This one is not 3.8 this time around. It's 3.6. This is because it's touching the what? The 3.6. So this is going to be 3.60. The next one is 11.6. Let's check whether the other is correct. Now the IA1 is what? 2.4. 2.4 here is 2.4. This also is also 2.4. For IA2, this one is what? 3.8. This one is 3.6, correct. This one is what? 5 points. This one is supposed to be what? This one is supposed to be 5 points. For I3, 5.10. 5.20, yes. For I2, that's 5.20. For this one also. So that's very, very correct. So I've cross-checked everything, is very correct. So I have gotten the what? The IA and the IB, 2.40 plus 2.40 divided by 2. It's going to be what? 2.40. So 3.8 divided by 3.6 is going to give you what? 3.70. We divide it, add this one with this one divided by 2, it's going to give you what? 3.70. Let's do it to confirm it. 3.80 plus 3.80 plus 3.60 divided by 2. 3.70, as I said earlier. If I add this one together, to give you what? 5.10. Add them together again, 7.50, because they are the same thing, 11.60. Now we have to find the log of I now. Find the log of I. Now I don't have calculator with me, I'm going to use logarithm table. If you have calculator with you, you can easily press your log on your calculator. But here I'm going to make use of what? My logarithm table. My logarithm table. So I'm going to the log of natural numbers, which is page 1, page 2 here. Log of natural numbers. Log of natural numbers. So, log of natural number that I have here is what to do for the log of 2.40. 2.40. So, if you want to look at this on the table, you have to what? Use your logarithm idea. You know, this is 1 and this one's going to be 0. So now check 24 under 0. 24 under 0 will be what? 24 under 0. 24 under 0 is 3802. Please press your own calculator, you get the same thing. So log 2.40 is 0.3802. Now here is going to be 0. Now log 37 now will give us what? Log 37 is 5682. 5682. Now also 0. Log 51. We have 7076. Then log what? 75 0. So log 75 here is what? Log 75 here is 8751. The last one is 11.6. Now we can always find out. So this one is going to be 1 point because there are two numbers. So we remove 1 point. So 11 under 6. 11 under 6. 11 under 6. 11 under 6. That is 0645. 0645. 0645. 0645. So that is log what? Log I. Now, next one is log D. Everything is also 0 because there are one number before, so this one will be 0 point. So 0 points. So 12 under 5. 12 under 5. 12 under 5. 12 under 5 is 0.0969. 0969. 1.5, that is 0.15 under 0. 15 under 0 is 761. 761. So 0.17 under 5. 17 under 5. 17 under 5. So that is 242430. So this is 0 point, then 20 under 0. 20 under 0 is 3010. 3010. You can see there is an increase. Then 0 point now 22 under 5. 22 under 5. 22 under 5 is what? 22 under 5. 22 under 5. 3522. 3522. So we have successfully what? Gotten our what? Values that we are going to use to plot our graph. Now, the next thing now, before we could hang our graph, before we can hang our graph banner or our graph book, we are going to what? Know the value we are going to plot on the graph. The first thing is to analyze or bring out your plotted values. Now, how do I bring out the plotted values? So I go back to the question: plot a graph of log I against log what? D. So I'm going to plot a graph of log I against log what? D. Log I against log D. Meaning that I need to bring out this approximate value of log I and log D before I can what? Really what? Plot it. You can see for log I now, the approximate what? The highest value I'm having here is 1 point. 1 point, approximately 1.1. Approximately 1 point what? 1.1. So if that be the case, so meaning that what? This is 1.1. So I want to approximate it now. I will rather approximate it to 1 decimal place, which is I'm going to use what? Approximate 1 decimal place now. So if I'm using 1 decimal place, what are the values I'm going to plot? So let me quickly just write it out somewhere here before we really what? I want you to note the plotted value here. The plotted what? The values to be plotted. Values to be plotted. Values to be what? To be plotted. So I have the log So we have the log I and the log what? D. 2, 3, 1, 2, 3, 4, 5. Now look at this for the log I, which is going to be on vertical axis. For here to approximately what? 1 decimal place, and this is going to be what? 0.40. To 1 decimal place, so it's going to be 0.60. This is going to be what? 0.70. This is going to be what? 0.90. Please follow. 90. This is going to be 1.10. 1.10. So that is that about that one. So the same thing applies to this. The same thing applies to this. If you want to use this one to 0.01, because this one is not getting up to 1. The highest number is 0.35. You can decide to 2 decimal place here, that is approximate what? 2 decimal place. So this one is going to be what? This one is going to be what? If I approximate to 2 decimal place, this one is going to be what? Approximate this one to 2 decimal place, this one is going to be what? This is 0.1, 0.10. This is going to be what? 2 decimal place now. This one is going to be 0.18. This one is going to be what? Is 2 decimal place. It's going to be 0.24. Because this is 2, this one is not up to 5, so you drop it. So this one is 0.30. This one is what? Is 0.35. 0.35. So these are the values you are going to plot on the graph. So let me quickly write this one down and clean the what? The board. I will write the table of value out now. These are the what? Value extracted from the table. We plotted on what? On the graph. Now we are asked to plot the graph of log I against log D. But not a graph of log I against what? Log D. Now the first thing is to think of the scale you have to use. No, I told you that what? This one now is approximated to 1 decimal place because of what? I just add 0 to it. It's approximated to what? 1 decimal place when we are approximating the other time. So it's going to be what? 1.1 0.90. You can see every of these ones having 0, 0. So it's approximated to 1 decimal place. So we are going to use what? 2 centimeter represent what? 1.0 because this is what? This is 1.10. So we are going to use the scale of 2 centimeter represent what? 0.1. So that we can get to 1.1 easily. So here I'm going to use what? The scale of 2 centimeter represents. Okay, let's put it here. 2 centimeter represents what? 0.1 units. 0.1 units. 0.1 units on log I axis. On log I axis. Now the next one is what? 2 centimeter represents 0. And let's look at this one is equivalent to 2 decimal place. So we can use 0.02, 0.02. It will take you to what? But when you look at 0.02, it will not take you to 0.35. So let's use 0.05. 0.05 on log D axis. On log D axis. So now how we done that? Now let's quickly think of how we are going to draw the line. Let's see. I pick a line from here. So now this is my so now with this now we have 0, 1, 0 now. This 0, 0 starting from the origin. This one, don't forget we use 0.1 here, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0, 1.1, and this is 1.2, which we didn't get to that place. Just let us leave like that. So this one is 0.05. This one is 0.10, 0.15, 0.20, 0.25, 0.30, 0.35, 0.4, 0.45. So that's that. This one is going to be log D axis. Alright, this one is log what? I axis. So with that now, you can plot the graph. This one is going to be what? 0.40 against 0.1. So when they join together, it's a point of what? Intersection. The point of intersection is our what? Is our location or position of the what? Of the point. Now this is 0.40 against 0.1. We have something here. Now the next one is 0.6. 0.6. 0.6 against 1.8. Look at this. For every total line here, represent 0.1. This one is 0. Look at this. Look at, we said this is 0.05, Abby. So for every two lines, 0.01. Now look at this. This one is what? This one is going to be what? 0.01, 0.02, 0.03, 0.04, 0.05. Now, if I want to count what? 0.18 now. This one is 1, Abby. This one is 15, 16, 17, 18. So 18, 296 means 0. So 18 again 0.6. 18 again 0.6. This point is our point. So the next one is what? 0.7 against 0.24. 0.7 against 0.24. This is 0.25. 0.24 is a 0.25. So 29 before 0.25 is 0.24. So 0.24 goes like this. 0.24 to meet what? Mr. 0.7. So 0.9 against 0.30, that was on the line. 0.9 against 0.30. So this one is happening on the point. The last one is 1.10 against 0.35. 0.35 against 1.10. 0.35 against 1.10. This is 1.10 here. Just put your words. Against 0.35. So that is that about that. Now let's quickly join this point together and decide and determine our slope. Now, if you look at this very well, can we take 3 out of this point? Yes, which means it is a perfect what? Graph. One is left, the other one is what? Okay. Can even take. So this is a perfect graph. 3 points, one below, one down. So that's good. And the last one here is to plot our last thing here is to plot our graph. I'm going to do that one now. We're taking it from here. Okay, it means this point is, take note of that. So now is our right angle here. Our right angle. So we can trace this one. So that's that. So we have the words. Here we are going to have the log I2, log I1, log I1. This is what? Log D2, then log D1. Log D1. So we have slope is equal to log I2 minus log I1 over log D2 minus log D1. So x will now be equal to what? What's log? Log I2 will be what? This is 0.91, 92, 93, 94, 95, 96, 97, 98, 99. 0.99 minus 0.40, 0.40, 0.40. This one is 0.40. So 0.40 divided by, no unit, don't forget that there's no unit here, divided by 0.34, this is 0.35, 0.34, 0.34 minus 0.10, 0.10, bracket close. So what do we have? Let's subtract this one from this one. What do we have? 0.59 divided by, when you minus this one goes 0.24. So when you divide it together, what do we have? We have our slope to be what? The slope to be 2.458. So 2.46, no units. Don't forget that this has no log, has no unit. So that's that about that. I've come to the end of today's class. If you haven't subscribed, please go and press the subscribe button and notification bell so that I'll update on this YouTube channel. See you next time and God bless you.